Hello, welcome to day 3, more related rates. We'll be taking more derivatives with respect to time and seeing how things are changing in the moment. I'll start my notes for today. Key, again, taking the dt of everything. So this turns out to be 12x squared times dx over dt. This is 24y cubed dy over dt. And I rewrite this as 5r to the 1/2. It becomes 5 over 2 r to the negative 1/2 dr over dt. We could also write it using primes instead of dx over dt. I'm going to pause it and I'll show you in a second. And as you can see, I've used x prime, y prime, and r prime instead of like the dx over dt. I don't care which way you do it. I think maybe today I'm going to work more with the x primes instead of the dx over dt, but either way is acceptable. And again, we're going to work with the Pythagorean theorem, and the derivative of the Pythagorean theorem turns out to be 2x dx over dt plus 2y times dy over dt is equal to 2z times dz over dt. If you want to clean it up, I'm going to change the color to orange. I get x dx over dt plus y dy over dt is equal to z dz over dt. This is the derivative of the Pythagorean theorem. We're going to use it a lot. If you want to write it with the primes, x times x prime plus y times y prime is equal to z times z prime. Again, this is the derivative of the Pythagorean theorem. What do these things mean? X is the length of a side, and x prime is the rate of change of that side. Okay, let's look at a real-life application of the equation I equals V over R, where I is the current in amps, V is the volts, R is the resistance in ohms. And we have a very special case where we have a voltage that is constant of 10. So I change my equation to I equals 10 over R, or 10 R to the negative 1. I'm going to take its derivative. I have di over dt is equal to negative 10 r to the negative 2 times dr over dt. And let's see, what do I know? Well, I know that my r is equal to 2 and my dr over dt is equal to 0.2. I can rewrite this as I prime is equal to negative 10 over r squared, because that's what r to the negative 2 is, times r prime. And I come over doing this and put in what I know. I prime equals negative 10 over 2 squared times 0.2. And when I do this, I get I prime, or my di over dt is equal to why put a negative there? 0.5. Oh, there's a negative because of the negative from the negative 10 amps per second. That is my rate of change of my current. Negative ½ amps per second. Okay, I've got this sphere again. I'm going to take its derivative of its volume. I get dV over dt is equal to 4 pi r squared times dr over dt. And I can plug in with what I know. I know my r is 4, and my dr over dt is 2 over r. So I get dV over dt is equal to 4 pi 4 squared times 2 over r. But I know that my r is equal to 4, so I can plug this in. So I get V prime is equal to 4 pi 15, and 2 over 4 is a half. And when I'm done, I get my v prime, or my dv over dt, is equal to 32 pi, and my units are going to be cubic centimeters per second. That is the rate of change of the volume of that balloon at that moment. Okay, for related rates, when we have these word problems, I gave this acronym DREDS, D-R-E-D-S. Draw a diagram, figure out what the rates are, figure out what equation you have to use, take its derivative, and substitute for what you know. This is what I'm going to do on every single time I have a word problem. Sometimes I give you the drawing, sometimes you have to draw it yourself. Okay, I have this situation where there's a ladder up against a wall. The ladder is 3 meters long. It's standing up against a wall, and the bottom part of the ladder, this part right here, is moving away from the wall. It's slipping away. At the moment, it is moving out at 0.1 meters per second when it is 1 meter away from the wall. So right now I know this ladder, which is side z, is 3. X equals 1. I don't really know what side y is in the moment, but I'll figure that out. Well, my Pythagorean theorem is x squared plus y squared is equal to z squared, or even better yet, is equal to 3 squared, and I get x squared plus y squared is equal to 9. I'm going to plug in 1. So 1 squared plus y squared is equal to 9. Y squared is equal to 8. So that side y is equal to the square root of 8. So I could say this side y is really equal to the square root of 8. So I know my 3 sides of the triangle. Okay, I redrew my triangle over here for the ladder, and I have the 3 sides. X was 1. The ladder z is 3, and now the height on the wall is radical 8 for the y value. Here's my Pythagorean theorem. Here's my derivative of the Pythagorean theorem that we've done already. What else do I know? Well, I know that this bottom side is moving out at 0.1 meters per second, and side z, which is the ladder side, its z prime is 0. Why is it 0? Because the length of the ladder is constant. It is never changing. So I don't know what y prime is. I don't know how fast. If this side is going out this way, well then this side should be falling down. I don't know what that is doing. So I have 6 things here. I know 5 out of the 6. Let me plug them in. 1 times 0.1 plus radical 8 times, I'm going to use prime, y prime is equal to 3 times 0. Well, I get 0.1 plus radical 8 y prime is equal to 0. I'm going to subtract it over. Radical 8 y prime is equal to negative 0.1. Divide by radical 8 on both sides. And I get y prime is equal to, when I put this in the calculator, negative 0.035, and this was meters per second. So when this side here, when it's 1 meter away, is slipping out at 0.1 meters per second, the top side of the ladder is falling at negative 0.35 meters per second. And since it is negative, it represents that it is falling, going down. So how does this change if my x value would have been 2 meters away from the wall instead of 1 meter away from the wall? Well, the way it changes is that I have this picture where side z is still 3 meters, side 2 is now 2 meters, side x is now 2 meters, and side y has changed, and now it's radical 5. So what else do I know? Well, this is what else I know. I know my x prime is still 0.1. That did not change. I know my z prime is still 0 because that ladder is not changing length. It is always 3. So that means its derivative is 0. My y prime is unknown. If I use my Pythagorean theorem of x times x prime plus y times y prime is equal to z times z prime, I substitute in what I know, I get 2 times 0.1 plus radical 5 times y prime is equal to 5. 3 times z prime, that I know, times 0, and I get 0.2 plus radical 5y prime is equal to 0. If I subtract it over and divide by radical 5, I get y prime is now equal to negative 0.089 meters per second. Again, it is falling. That's why y prime is negative. But how does this compare to before? Well, what do we know? X prime was the same, but y prime increased as x increased. That means the farther that x gets away from the wall, the faster the top part of the ladder is going to fall down the wall. Okay, another word problem. Again, I'm going to draw my picture of my observer that's standing 4,000 feet away. That's the x value away from the launch pad of this rocket. And the rocket goes 1,000 feet per second. I have the scenario when I want to figure out how the distance between them is changing when the rocket is 3,000 feet off the ground. So right now I have x equals 4,000, y equals 3,000. Z I have to figure out by using my Pythagorean theorem. And if I do 3,000 squared plus 4,000 squared equals z squared, I get z is equal to 5,000. So right now z is 5,000. What else do I need to know? Well, I need to know what x prime is. I need to know what y prime is. I have to know what z prime is. Well, let's see. Z prime is what I'm going to try to figure out. Y prime is the vertical change of the rocket, which is 1,000. And x prime is equal to 0 because the distance between here is never changing. It is always the same. So if I take the derivative of my Pythagorean theorem, x times x prime plus y times y prime is equal to z times z prime. Let me fill in with what I know. 4,000 times 0 plus 3,000 times 1,000 equals 5,000 z prime. I get 3 million is equal to 5,000 z prime. And I get a final result of z prime is equal to 600 feet per second. So in the moment, right now, this distance right here, this z prime between the person and the rocket is changing at 600 feet per second. Okay, here's my scenario. Here's my little drawings. I know they're crude, but I don't really care. Okay, we have a gas station. A police car is traveling towards the gas station from the east. That means he's going east to west, chasing a stolen truck, which is traveling north away from the gas station. Let's see. Let's pick on somebody. We'll call it Frankie's gas station. And the truck is being driven by Jack Wren. And the police car is being driven by Matt Christopher. So this is our scenario. And what do we have? So we have to figure out, we have x x prime, y, y prime, z, and z prime. We have all 6 of those things. We might not know all of them, but we'll try to figure out what we can. We know that the distance for x, the police car, is 3 miles away, and it is going negative 100. And the reason why it's going negative 100 is because it is going left. To the right is positive, to the left is negative. Y is the truck. It's 4 miles, and it's going 80 miles per hour. And the way I could figure out z is my Pythagorean theorem of 3 squared plus 4 squared is equal to z squared. So my value for z is 5. So again, I'm going to use my Pythagorean theorem. Derivative x prime plus y prime is equal to z times z prime. And I'm going to fill in with what I know. And what do I know? I have 3 times negative 100 plus 4 times 80 is equal to 5 times z prime. And I get negative 300 plus 320 equal to 5z prime. Move this up. And I'm going to get 20 equals 5z prime, or z prime is equal to 4 miles per hour. So what is going on here? That the distance at this moment is increasing on that diagonal distance z between the police car and the truck, since z prime is positive. That's what's going on. Now what happens if we change this up a little bit, and I'm going to make y prime 70 instead of 80. So I'm going to still have 3 times negative 100 plus 4 times 70 is equal to 5z prime. So I get negative 300 plus 280 equals 5z prime. And now I get negative 20 equals 5z prime, or z prime equals negative 4 miles per hour, which means this distance is decreasing since z prime is negative. Okay, all my notes are on the portal. You can pause this if you want, and you have to do a daily assessment. Thank you.